different I and V, you have learned resistance R. 3.2 resistance, 3.3 EMF and internal resistance. And then today we're going to learn about 3.4 energy and electrical power. Ni pun senang je, simple je. Okay, current and potential different. Current I, what is current? Current is the rate of charge flow. So remember current. I Q over T. Okay, I Q over T, the rate of charge flow. The rate of charge flow in a conductor. Rate of charge. Okay, we have Q over T here, the rate of charge. How many charge flow in 1 second? That is current. 3.1. And then we learn about potential difference V. Okay, potential difference is work done or how much energy is used to move one charge, to move 1 coulomb of charge between 2 points. Okay, V, that is V. Okay, W, how much work or how much energy is done to move 1 coulomb of charge. Okay, W or E lah, work or energy is used to move 1 coulomb of charge from one point to another, from A to B or from C to D. This one from one point to another. Okay, and then 3.2, we have R, resistance. We have ohmic. Okay, ohmic conductor and non-ohmic conductor. Ohmic conductor means the conductor, dia punya characteristic follow the Ohm's law. Okay, ohmic. So dia punya graph directly proportional lah. Okay, V against I directly proportional. So dia punya R we can get from the gradient of the graph. Okay, for ohmic. Non-ohmic. Okay, non-ohmic is increasing. Okay, the resistance increase. This one affect by the temperature. Non-ohmic. So we can compare this ohmic and non-ohmic by using ohmic. We use wire. Okay, a wire. Non-ohmic we use a bulb. Okay, the bulb, filament bulb. And the resistance increasing, keep increasing because inside the bulb we have the filament, coil of filament that need to be heated first. So it need temperature. Now when the temperature increase, the resistance will also increase. So the graph increase. Okay. That is for non-ohmic. Ohmic is for wire lah, copper wire, nichrome wire. Okay, and then 3.3, we learn about EMF and also small r. Okay, EMF, electromotive force. So EMF, dia punya definition, okay, almost same with potential difference, V. Okay, sama je maksud dia. Okay, work done to move 1 coulomb of charge. Yang beza dekat belakang. Work done to move 1 coulomb of charge in a whole circuit. In a whole circuit. This one from one point to another. Okay. Potential difference. For EMF, dia punya definition in a whole circuit. To bring the charge in a whole circuit. And then we have internal resistance, which is the resistance inside the battery itself. Resistance inside the battery. The battery that we provide inside the circuit. That is internal resistance. 3.2 yang big resistance is this one for the other electrical component inside the circuit. Okay, maybe the resistance for the bulb or the resistor itself. Okay, resistor. Resistor dulu you belajar masa form 3 ya. This one is fixed resistor lah yang ada jalur dekat hujung dia, and then dekat satu kepala dia ada gold, ada silver. Okay, gold, warna gold ataupun warna silver. So dia punya value pun berbeza lah. Yang ni yang dulu you kena ingat ni, dia punya colour-colour ni. Ada colour brown, red, and then it has its own value. Kalau you masih ingat lah. Belajar tak RBT ataupun KH. Okay, this one is fixed resistor. Variable resistor, we use rheostat. Rheostat lah. Okay, now 3.4. 3.4 kita masuk energy. Okay, mana-mana physics pun ada energy lah. Okay, start from force and motion, we have kinetic energy, potential energy, and then for the spring, elastic potential energy, gravitational energy. So same goes to electric, we have electrical energy and power. Okay. Kita cuma main dengan dia punya formula sahaja. Main dengan formula. Okay. Tadi yang tak ada apa jawapan . Okay, we go to the relationship. Actin. Tak cukup 30 ni. Okay, we look at the relationship between electrical energy, voltage and current. Right. So we take the voltage first. Okay, number 1, or potential difference. Okay, this one we know that V equal to E over Q. E over Q. How much energy or work to bring or to move 1 coulomb of charge in a conductor. Okay, this is potential difference along the circuit, in the whole circuit. Okay, V equal to E over Q. Yeah, this one between 2 points, between 2 points, sorry. Yang whole circuit to EMF. Okay, now from voltage we can convert the equation into energy. So tukar dia punya kedudukan untuk E equal to V times Q. Okay. And then we know that Q equal to IT from the equation of current. Okay, number 2, current. From current, I equal to Q over T. How much charge flow inside the conductor in 1 second? Current is how much charge that flow in a wire in 1 second. That is I. So from I, you convert Q. Q equal to IT. Okay. Substitute into the equation of energy. E equal to VI T. Okay. Right, From the potential difference, okay, we convert the Q into IT, so we get E equal to VI T. Leh. Okay, now next E equal to VIT. Kita relate lagi dengan power. Okay, relate dengan power. So we know that power biasa dekat tajuk lain, dekat topik lain, power is the rate of energy. Power is the rate of energy. Means that E over T. Rate of work done. Rate of energy. Rate of energy or rate of work done. So P equal to E over T. Right. So from P equal to E over T, we just substitute the E inside the equation of P. So yang E tadi yang dekat atas ni, E equal to VI T, right? So substitute, replace, can get P equal to IV. Okay. So dekat sini, we know the power produced from the electrical energy is P equal to IV. So tak adalah E. Tak ada lagi E, tak ada lagi T. So we just use P equal to IV. Okay. Dah? Right. Next. Okay, you can see this electrical appliance is rice cooker. Okay, the electric rice cooker will use 700 joule. Dekat sini you kena tengok dulu dia punya label. Okay, label. See the label for each electrical appliance that you have in your home. So kita akan tengok dekat label, dekat wire ataupun dekat belakang appliance tu dia akan tulis watts. Okay, watts. So this watts refer for power. Okay, 700 watts. And then the voltage. Okay, voltage 220 to 240 volt. Okay, sesuai lah untuk kita punya amount of the voltage supply to our home until 240. So this one is potential difference. We have P, we have V. So biasa kalau soalan SPM dia akan tanya what is the meaning of 700 watts and 240 volt that is labeled on a certain electrical appliance. Dia akan tanya tu. Okay. What is the meaning of 700 watts and 240 volts? Okay, soalan straight tanya macam ni. So, how to answer? Okay, look. Tengok dekat ayat dekat atas ni, the electric rice cooker will use 700 joule of energy, okay, in 1 second when a voltage of 200 volt is supplied. Okay, mesti ada 1, 2, 3, 4. Mesti ada 4 term. Okay, kalau soalan tanya what is the meaning of 700 or any value lah. Kalau soalan bagi apa sahaja value dekat sini, you cuma explain balik. You just change the letter of watts into joule. Tukar kepada energy. Okay. So the meaning of this one is 700 energy, tukar kepada energy. Watt ni tukar kepada energy. Kalau you still continue using watts, so your answer is wrong lah. So you need to change the watts into energy. 700 energy is consumed or is used in 1 second when a voltage of 240 volt is supplied. Okay, mesti ada 4. Ada value, ada energy, perkataan energy, ada second in 1 second, and then voltage. Voltage apply. Supply, when supply. You punya ayat boleh tukarlah mana yang nak buat dulu. Tapi make sure mesti ada keempat-empat term ni dalam you punya sentence for the definition of this one. Okay. Kena ingatlah. How much energy is used in 1 second when 240 voltage is supplied. Okay, ataupun voltage V dekat sini you directly convert to voltage. Tulis terus voltage is supplied. So tak payah panjang-panjang sangat. Cuma wajib compulsory lah. Mesti ada 4 term dekat sini. Okay. Okay, next. Ini yang tadilah. Okay, from the equation E equal to VIT, we convert into P equal to IV or VI. Okay. Okay, so maksudnya dekat sini you kena tahu basic lah daripada force and motion yang kita belajar tu, yang power semua tu. So you kena ingat balik P E over T. And then bila masuk kepada topik electrical energy ataupun soalan berkaitan dengan electrical energy, so you need to change the equation. Become P equal to IV. Because electric, we usually use this value lah, current and voltage, current and potential difference. Kalau topik lain tak ada current, tak ada voltage. So special for electrical energy, we change the power equal to IV. Okay. Kalau untuk force and motion, kita guna inilah. P equal to E over T. So yang E ni masih ingat tak? Kalau force and motion, yang E ni equal to W, work done equal to force time distance. Tu kena ingat balik Okay. Right, from Ohm's law, dia expand lagi equation. Okay. In case the question asks you, kalau tak ada I, what say if the question doesn't have I? So you just change the V. Okay. From P equal to IV, okay, we know that V equal to IR, then I equal to V over R. So dekat sini for the first one, it change the I, expand the I. Then we will get number 1, V square over R. Okay. And then the second one, if the question doesn't have V, tak ada V. Dalam soalan dia tak bagi nilai V, nilai voltage. So kita boleh tukar V kepada I. V equal to IR. So P equal to I square R. Just multiply lah. Tukar. For the first one, change the I. Okay, tukar I. Yang kedua, you tukar V. From IV, you tukar V. Okay. Boleh SI unit masih samalah. Watts or joule per second. Joule per second. Energy is joule. Time is second. So, joule per second or watts. Okay Ada soalan nak tanya untuk yang question ni? Tak ada. Ingat balik semua yang 3.1, 3.2, Q equal to IT, Q equal to NE. Right, solving problem that involve electrical energy and power. Okay, yang ni tengok soalan lah. Ini dah bagi cara penyelesaian. We have 6 volt battery to light up a lamp. If the current is 0.7 ampere, what is the amount of electrical energy used for 1 minute? Okay, so use the equation. Look at number 3, E equal to VQ. Okay, E equal to VQ. Dia nak cari E kan, dia bukan cari power. Kalau dia nak power, so we can determine the power because here we have V and we also have I. Okay, we have I, we have V in the question. But now the question was energy in 1 minute. Okay, so energy E equal to VQ. Okay, from the equation V equal to E over Q. So E equal to VQ. VQ, Q tak ada. How to find Q? Q equal to IT. Recall balik yang depan-depan. So VIT. Q ni expand to IT. Okay, Q. How many charge? So barulah ada. So substitute the value 6 volt times 0.7 ampere times T. How much is T? Okay. So for the time, make sure ni jangan careless lah. Time mesti dalam second. The question give you 1 minute. So 1 minute convert to second is 60 second. Right, and you get the answer 252 joule. Okay, masa tengok betul-betul. Jangan lupa untuk tukar kepada saat. SI unit for time is second. Okay. Example 2. Ni contohlah dia akan bagi macam ni and then write the definition. What is the definition for 240 volt and 32 watts? So you punya answer 32 joule of energy is used in 1 second when 240 volt is supplied. Okay. Right. Calculate the lamp resistance. Dekat sini kita ada V and then power. So dia nak resistance pula. Okay, the answer wants you to calculate the resistance. Just use the equation P equal to IV. Tapi R tak ada kan? So tukar. P equal to, kita ada V. So V square over R. V square over R. Dan barulah cari R. Cari R. R equal to V square over P lah. We change the equation to find the R. Okay, boleh ya? Okay, for second question, the current flowing. Find the current flowing through the lamp under normal condition. Find I. So I we just use P equal to IV lah. Okay. Nak cari I sahaja kan. So P dah ada, V dah ada. Just use P equal to IV. No need to change P equal to I square R. No need. Okay. Guna sahaja P equal to IV. Okay. C. Find the electrical energy that is supplied for 3 hours. 3 hours in kilojoule. Kalau ada highlighter, nanti dalam masa SPM bawa highlighter ke ataupun tak nak guna highlighter, you just underline the question yang mana dia punya word yang you perlu kira ataupun yang penting lah. Okay. So dia nak energy for 3 hours in kilojoule. In kilojoule. So find energy. E equal to PT. Okay, we know that P equal to E over T, rate of energy. Okay, so E equal to P times T. P times T. So P is 32 watts. Okay, inside the question, 32 watts times T. T, you must convert again into second. 3 hours times 60 minutes times 60 seconds. And then you get 10,800 seconds. Okay. Dapat jawapan, baru tukar kepada kilojoule. Divide by 1000. This one you divide by 1000 lah, kilo. Kilo 1000. So 345.6 kilo joule. Ikut soalan. Soalan nak apa? Boleh So if you just stop until 345,600, you cannot get the full mark satu saja. Satu mark saja. Kalau jawapan betul baru dapat 2 markah. Okay, this one the difference of power rate and energy use in different electrical device in compact fluorescent lamp and in light emitter diode. Okay, LED dengan CFL. Ini nak tunjuk beza saja. So ini pun dia guna equation for energy. Nak bandingkan CFL dia punya power 0.04, LED 0.012. So LED use less power, less energy consumption compared to CFL, compact fluorescent lamp. So means that LED has a higher efficiency and more energy saving compared to CFL. Macam mana dia tahu more energy saving? Once you calculate the cost of energy consumption. Okay. Satu unit, the value for 1 unit of energy usage is 20 sen lah, 0.218 ringgit Malaysia. Sama. CFL pun sama untuk 1 unit. So bila kita compare both of these lamp, we can see that LED dia punya bill less than CFL. So LED is more energy saving. Lihat. Okay. Ini cost ni cuma explain dekat contoh ni je. Alright. The cost of electricity consumption ni you dah belajar dekat form 3. Form 3. The cost of electrical energy consumption. Cost dia berapa? Berapa bil elektrik yang you kena bayar, macam mana nak kira? You kena kira dia punya energy dulu. Okay, energy. Kira energy. Macam mana nak kira energy? Energy equal to PT. Power times T. So kira berapa dia punya power, how much power you use every day, in a month or in a year. Okay, kira power. Power must be in kilowatts. Kilowatts. Okay. Yang ni you kena take note lah. Untuk yang cost of electricity consumption, mesti power dalam kilowatts. So kalau dia bagi 200 watts, you must convert into kilowatt. Become 0.2 kilowatts. Kena kira. And then time. Time must be in hour. Time must be in hour. Okay, untuk question yang lain, time in second. Tetapi untuk yang electricity consumption, untuk bayar bil ni mesti guna dalam hour lah. Sebab kita bayar bil, kita ikut 1 bulan kan. Kita tak guna 1 hari bayar bil, 1 hari bayar bil. So kita guna dalam hour lah. Dan you punya rumah ada apa? Mesin. Mesin you guna berapa kali, berapa jam, berapa hari. So kalau sebulan, kena darab dengan 30 hari lah. 1 hari 24 hour. Okay. 1 day 24 hour, and then kalau dia cakap in a month, so you must calculate lah, either 30 or 31 days. So banyak lah dekat sini. Okay, the value for hour ni banyak ah. Ini kena tengok betul-betul soalan nak apa. Dia punya masa tu tengok berapa hari, berapa jam guna kipas, berapa jam guna lampu. So baru you times with power, kilowatts. Okay. The power also depends on the electrical appliance lah. Kalau satu je alat yang dia guna dalam soalan, so satu je lah. Kalau dia guna banyak, so you must add all lah. Okay. Cari satu-satu and then you find the sum of all the cost. Okay, contoh dekat bawah ni. Okay, quantity ada berapa. Rice cooker. Power untuk rice cooker berapa. Berapa jam guna. Okay, and then baru cari total energy use. A times B times C. 2 rice cooker. Power berapa? 100, let's say. And then berapa jam guna. Right? So this one, sorry Kalau 100 watts, 0.1 lah kilowatt. Time berapa jam? Satu rice cooker, 1 jam. Kalau 2 rice cooker, okay, so times 2 here. This one is 1 hour lah. Okay, baru cari total. Okay. Okay. And then nak cari cost tadi, lupa Yang cost tadi, bila dah dapat semua total for energy, okay, and then baru you darab berapa unit, okay, untuk let's say for first 200 unit, the value is ringgit Malaysia 20 sen lah. Okay, so baru you darab dengan 20 sen. Okay. Kalau lebih 200, let's say the next 200, this one 0.2, 20 cent. This one 0.3, 30 cent for next 200. If your energy here more than 200, let's say the energy you got keseluruhan contoh sebagai 240. 240. Okay, so you cari dulu first 200, first 200 times 0.2 and then baru you tambah dengan 40 darab 0.3. Baru kira kos berapa ringgit. Campur. Okay, tambah. Cari jumlah. Ini tengoklah soalan tengok soalan. Tak ada dekat sini. Dia skip. Maybe tak ada kot. Yang ni sebab yang ni level form 3. Semua saya remind balik lah. Okay. Right. Then this one step in reducing household electrical energy usage. Ini semua kalau yang jenis aplikasi dalam daily phenomenon. Okay. You kena logik lah. Kena baca juga. Kena baca. Sebab nanti dia akan tanya maybe dalam paper 2 ataupun paper 1 objektif pun ada Ini dah biasa kan? Close all windows, doors kalau guna air conditioner. Switch off electrical appliance when not in use. Okay, use only full loads of laundry. Kalau guna using machine, takkan satu helai, dua helai nak guna machine. Melampau lah Okay, and then use energy saving lamps to reduce energy consumption. So this one refer to LED. Kalau ada lampu LED. So avoid using a bulb yang biasa ni. Yang ada filament dekat dalam tu dia guna banyak energy and then banyak heat. Dia punya sebab dia perlu panaskan filament baru keluarkan cahaya. So more heat energy is waste. So kita pakai LED lah sekarang. Sebab kita ada CFL, compact fluorescent lamp, yang panjang ataupun yang curl tadi. Okay, and then LED yang latest. Okay. Right, go to formative practice. The output power of a battery is 80 watt. P. Determine the electrical energy that is supplied by the battery in 10 seconds and in 2 hours. So yang ni senang lah. Okay. E equal to PT. E equal to PT. So just multiply by the time in second. So yang ni tak perlu tukar. Yang B ni perlu tukar lah. 2 hours time 60 second. Right. Tapi dia dah bagi 80 watts. And number 2, if the cost of electricity is 30 cent per unit, calculate the cost of using 600 watts LED television for 8 hours. So yang tadi total energy use must be in kilowatt hour. Kilowatt hour. Baru you times with 30 cent. Okay, 30 cent. Ni kena tulis lah. Either you use 30 cent or ringgit Malaysia 0.3. Okay. So this one 600 watts must change to kilowatts. Divide by 1000. And 8 hours. Okay. Dah betul 8 hours because we use the unit hour. And then times 30 cent. Okay. 1 kilowatt hour. Ni dah betul unit kilowatt hour. For half an hour. So half an hour equals to 0.5 lah. 0.5 hour. 1 times 0.5 times 0.3 ringgit Malaysia. Baru dapat dia punya cost. Okay. Boleh Ada soalan nak tanya? Ada soalan? Tak ada. Ni faham terbalik ni. Jadi apa? Tengok baliklah revision ni. Sekejap. Um, 25. Okay, kita dah habis yang chapter 3. Kita boleh masuk chapter 4. Chapter 3 ada nak tanya. Okay, kita ada 4 unit dalam chapter 3. Current and potential difference. Okay, I Q over T, V equal to W over Q. Okay. Dan kita ada electric field. Electric field ni depends pada charge. Ini E equal to F over Q untuk individual charge. Okay. Positif or positif, negatif. So kita nak cari the electric field experienced by the charge when we put the test charge. Okay. Q is the test charge lah. Kita nak tahu the other charge, the electric field produced by the other charge. So we use E equal to F over Q, force over Q. Q is the test charge. And then the other one, the electric fields between two parallel plate. So remember the parallel plate. So this one depends on the potential difference or voltage that we supply to the plate. Okay, berapa voltage the battery or power supply. And then D refer to the distance between the plate. Okay, distance between the plate. Okay, jarak antara plate lah. Okay. Behavior of charge particle in an electric field ini refer to, this behavior refer to the coated, aluminium coated of the polystyrene ball between the two plate, between charge plate, positive and negative charge plate. And explanation you kena explain lah. Okay, wide swing to and fro. Kenapa dia boleh swing? Okay, and then one more is the spread of the candle flame. Okay, kenapa salah satu, why this one is wider, why this one is smaller spread, difference spread of flame. Kenapa? Okay. Tengok balik yang ni. Kenapa ni yang ni besar, yang ni kecil? Okay. So this one must depends on the plate also. Okay. Ingat ke tak ni? Right. So this one depends on the plate use lah. So kalau the left side use negative plate, so more, okay, more ionized molecule of the flame will attracted to negative. The positive one more to negative because positive have bigger mass than electron. Proton, the charge, the proton, the positive charge have a larger mass than negative charge or electron. So bigger spread to negative plate. Okay. Right. Potential difference V equal to W over Q or E over Q. Okay, jangan confuse dekat sini. Kita boleh guna W ataupun E over Q. Okay. And then second is resistance. Resistance factors. Kita ada ni yang tadi saya explain, ohmic and non-ohmic. Okay. Ohmic and non-ohmic conductor, graph dia ada yang straight, this one directly proportional, this one is increasing. Okay, for non-ohmic. Factors that affect the resistance are equal to rho L over A. And then tambah satu lagi temperature. So depends on 4. Okay. Satu lagi temperature. Resistivity. Is it a good conductor? Kalau dia good conductor, dia punya resistivity sangat rendah. Easy for current to flow. Okay, resistivity. This rho refer to resistivity. Not density. Kalau density lain lah. Density formula dia P rho equal to M over V. So yang ni density, yang ni lain. Okay, yang ni kita refer kepada resistivity. Resistance equal to resistivity times length. Length over cross sectional area of the wire ataupun diameter wire. Okay, area, not diameter. Okay, length L, cross sectional area A, and then resistivity rho. Okay, the longer the wire, the resistance will be higher also. Okay, area. Look at area. Larger area, resistance will be decrease. Okay. Larger area, smaller resistance. Right. resistivity samalah, higher resistivity, so dia punya resistance tinggi lah. Ni lebih kurang sama resistivity dengan resistance. Right, and then temperature, higher temperature, resistance also higher. Okay. And then application in heating elements and electrical wiring, ini paper 2. Okay. Paper 2 yang ni. Heating element, saya dah inform. Kalau heating element dia punya resistivity atau resistance mesti tinggi. Okay, because it need to provide more heat energy. Heating element kan, so kena guna banyak tenaga dan juga haba untuk panaskan bahan. Okay. To heat up faster. Heat up faster. Do not write, jangan tulis cepat masak. Cook fast. Cannot. Kita mesti guna perkataan ataupun term untuk fizik yang sesuai. Okay. Mesti read dengan konsep. Tak bolehlah nasi cepat masak, daging empuk, cepat lembut, soften the meat. No, cannot. Must use heat up faster. Okay. Ataupun increase the heat energy. Right. And for electrical wiring kita tak nak wire tu panas macam heating element. No. So electrical wiring kalau boleh kita nak reduce dia punya temperature, tak nak bagi dia cepat panas. Nanti kalau panas, apa jadi pada fuse dalam plug? The fuse will melt and break down the circuit. So electrical wiring mesti dia punya resistivity low. Low resistivity and low resistance. Okay. Jangan confuse. Jangan anggap semua electrical appliance mesti high resistance ataupun low resistance. Depends. Depends pada electrical appliance. Okay, then the type of conductor we have, dia punya resistivity dia pun berbeza. Conductor, non-conductor, non-conductor refer to insulator lah. Okay, penebat plastic, rubber. Okay, then semiconductor either it can it is a insulator, okay, but not dia boleh jadi conductor tapi not as good, not good as a real conductor. Dia boleh dua-dua, dia tengah-tengah. Okay, semi ni dia tengah-tengah lah, semi, in between. Dia boleh jadi good insulator, dia boleh jadi good conductor. Okay. And then superconductor. Okay, superconductor yang ni dia punya resistance almost zero. Okay, when it reach certain temperature that we call it critical temperature. Okay, superconductor. Okay. So yang ni kalau critical temperature ni lower than zero lah, negative 200 something. Okay. So baru dia punya resistance zero. And then when the resistance is zero, we call it superconductor. Superconductor material. Okay. Right, next. Okay, yang ni the equation. EMF 3.3 internal resistance. Okay, EMF, remind balik dia punya definition. Okay, E equal to E over Q also. Sama dengan voltage, sama dengan potential difference, E over Q. Work done or energy used to move one coulomb of charge in the whole circuit. Whole circuit, tukar yang tu je, whole circuit. Okay, and then internal resistance is the voltage drop. Voltage drop in the battery. Okay. So yang ni, yang EMF ni dia lebih kepada bateri ya, lebih kepada bateri. Bateri yang kita guna. Okay. So, kalau soalan tanya voltage drop ataupun internal resistance, awak kena tengok pada bilangan bateri, susunan dia macam mana. Okay, arrangement of bateri lah macam mana, series or parallel. Okay, tengok nak cari dia punya internal resistance for all the battery. Kalau ada 3 bateri, so internal resistance dia pun berbeza lah. Yang ni kalau soalan tanya tentang internal resistance small r. Kalau soalan tak tanya internal resistance, so kita balik kepada yang asal, yang bigger r, in series and parallel circuit. Okay, and then we have electrical energy and power, EVIT, buka kepada IV. Okay, ini semua depends pada soalan. And then the cost of energy consumption, kilowatt hour, time cost. Okay. Dan yang ni you just convert the Ohm's law into the equation. Tukar sahaja. From P equal to IV. Sama ada you tukar I ataupun you tukar P. Okay. Ini dia tukar I, yang ini dia tukar V. Tak ada V. Ini tak ada I. So depends on the question. Right? Dan jangan lupa cost of energy consumption mesti in kilowatts an hour. Kalau 30 minit tukar kepada hour. Okay. Right. Okay, sampai sini. Nanti tolong buat latihan upload. Kat sini yang masuk ni mesti semua yang account MOE kan. So masuk GC. Saya bagi 2 page untuk elektrik. Kalau ada modul, boleh guna modul. Okay, chapter 3. Mana? Page 131. Okay, modul. Page 131, 132. Dia punya pengiraan kilowatt hour sahaja. Macam mana nak kira. Yang depan-depan tu semua equation. Senang. Okay. Kalau boleh habiskanlah semua. Nak dapat A memang tak ada cara lain lah. You habiskan satu buku modul tu, confirm lah dapat A. Jangan tiru jawapan pula. Buat dulu baru tengok jawapan. Exercise kan. Exercise kena buat lah. Tak ada exercise, tak ada apalah. So kena banyak exercise. Dah habis modul, cari lagi past year question ke. Dah kena start lah past year question. Tapi you punya exam bulan 3 kan, next year. Banyak lagi masa. Okay. Thank you class. Thanks for join visit class 24. 6 orang siapa ni, tak ada ni. Pengetua suruh cari. Setiap guru subjek tengok siapa yang selalu tak hadir. Okay, thank you. Bye.